Hello friends, welcome back to EduSeeker YouTube channel. Here we are going to look at the foundation of chemistry. There are 3 parts of this section. So, in this video reveals the second step part 2 which related to thermodynamics. First of all, want to say that if you are new to our channel, subscribe our channel and also click the bell icon to get notifications of our latest videos. So, let's get started. Thermodynamics is a branch of physics that deals with heat, work, and temperature. From the second video of our video series, we introduce basics about work. It is linked in description below. According to the definition of thermodynamics is the systematic discussion of the transfer and transformation of energy in bulk matter. Get to know what is bulk matter, the link mentioned below in the description box. When we take the title Thermodynamics, there are 2 central concepts of thermodynamics. What are they? They are internal energy and entropy. Internal energy is the property or state function that defines the energy of a substance in the absence of effects due to capillarity and internal electric, magnetic, and other fields. Entropy means the measure of system's thermal energy per unit temperature that is unavailable for doing useful work. Heat capacity also a related application as internal energy and entropy. Heat capacity defined as the amount of heat required to change the temperature of given amount of matter by 1 Celsius. Let's see laws of thermodynamics. In the first law of thermodynamics, in a process that transfer of matter, the change in internal energy delta U of a thermodynamic system is equal to the energy gain as heat Q less the thermodynamic work W done by the energy of its surroundings. The internal energy is the total energy of system. The first law of thermodynamics states that the internal energy is constant in a system isolated from external influences. The internal energy of a sample of matter increases as its temperature is raised, and we can write it as delta U equals C delta T, where delta U is change in internal energy when the temperature of the sample is raised by delta T. The constant C is called the heat capacity of the sample. If the heat capacity is large, this remark can be expressed in physically more significant way by inverting it. If the heat capacity is large, then even a large transfer of energy into the system leads to only a small rise in temperature. Enthalpy is a property of a thermodynamic system and is defined as the sum of the system's internal energy and the product of its pressure and volume. In this short video clip, you can see mass and temperature constant. When pressure increases, volume decreases. The equation H equal E plus PV. E stands for energy, P stands for pressure, V stands for volume. P and V are altogether considered as work. The internal energy and enthalpy of perfect gas for which PV equal nRT are related by H equal E plus nRT. In second law of thermodynamics, defined as the observation that the entropy of isolated system left to spontaneous evolution cannot decreases as they always arrive at a state of thermodynamic equilibrium where the entropy is highest. If all processes in the system are reversible, the entropy is constant. Entropy is an isolated system that is not in equilibrium will tend to increase over time until it reaches a maximum equilibrium level. If you keep the door open between 2 adjoining rooms of different temperatures, the cooler room will become warmer and warmer room will cool down until they both reach the same final temperature. This is randomness of the particle. The entropy of a system and its surroundings is of the greatest importance in chemistry. because it enables us to identify the spontaneous direction of a chemical reaction and to identify the composition at which the reaction is at equilibrium. In a state of dynamic equilibrium, which is the character of all chemical equilibria, the forward and reverse reactions are occurring at the same rate and there is no net tendency to change in either direction. However, to use the entropy to identify this state, we need to consider both of the system and its surroundings. This task can be simplified if the reaction is taking place at constant temperature and pressure, for then it is possible to identify the state of equilibrium as the state at which the Gibbs energy of the energy system has reached a minimum. The Gibbs energy is defined as G equal H minus Ts. The Gibbs energy or the free energy is a measure of the energy stored in a system that is free to do useful work such as driving electrons through a circuit or causing a reaction to be driven in its non-spontaneous, unnatural direction. So that's all gonna be from today's video. If you like this video, give a thumbs up and leave a comment if you have any comments, and thank you.